The function g is given right here. The derivative of the function h is given by this. In what intervals is h decreasing? Okay, to find out intervals where h is decreasing, we have to do the first derivative test. Here, the derivative of h is given already. So what we need to do is we have to simplify this and do the first derivative test. So h prime of x is equal to, here we have g of x. So we can factor out g of x, 1 plus 2 times g prime of x. G of x is equal to x squared minus 8x plus 15. And if we factor this trinomial, that's x minus 5 times x minus 3. So this is equal to x minus 5 times x minus 3 times 1 plus 2 times g prime of x. What's g prime of x? That is 2x minus 8. So 2x minus 8. So this is x minus 5 times x minus 3 times, if we simplify this expression, that's 4x plus 1 minus 16, so minus 15. 4x minus 15. And all of this expression, which is equal to h prime of x, that is equal to 0 when x is equal to 5, or 3, or 15 over 4. Now, let's draw the line. This is number line x. We have 3, least number. Greatest number is 5, and we have 15 over 4. That's 3 point something, between 3 and 4. So we have 4 intervals. Let me write h prime of x here. Now, if we substitute any number less than 3, maybe negative 4 for x, then this is negative, negative, negative. So 3 negatives are multiplied together. Then this is negative. For this interval, if we substitute maybe 3.1, that's going to be positive. Here, substitute maybe 4, then that's going to be negative. If we substitute 6, that's going to be positive. Let me give you a tip. When you test each of these intervals, if the expression has linear factors only, then the sign always alternates. If you find out this is negative, then next one is positive, the next one is a negative, positive. Always alternates. So we know that h is decreasing in this interval, increasing, decreasing, increasing. Now, back to the question. What intervals is h decreasing? H is decreasing when x is less than 3, or when x is between 15 over 4 and 5. Or in interval notation, from negative infinity to 3, or 15 over 4 to 5.